Right, here's another video from my No-frills playlist. These videos are ideal if you've got a test coming up and you just want to know how to score marks with a bit of understanding as well. Right, so this is about acceleration, which is a very common topic, so you'll probably score a lot of points here. The main things to get out of it is to know what acceleration is, to know how to calculate acceleration, and to know what acceleration of free fall is, and how to carry out an experiment to calculate it. Now that could be worth 6 marks. So what I say to my students, how to understand acceleration: if you're going to buy a car and you wanted one with a fast acceleration, what information would you need to know? Well, you'd walk into the sales shop and the person would probably tell you that the car will go from 0 to 60. So that's a change of velocity, and then how fast or how long it's going to take for that change to happen. So if there was another car that went 0 to 60 in 5 seconds, it does the same change of velocity in a shorter time. That means the acceleration will be bigger. That's the way to think about it. So 0 to 60 is your change of velocity, and then 7 seconds is the time that it took for the change to happen. So from that, what is acceleration? Well, for 1 mark in an exam, just tell the examiner that acceleration is a change in velocity per second, which is what I've just said. I like to base my explanation on the calculation, which you'll see in a second. You could also say that acceleration is a rate of change of velocity. A rate of change just basically means when something happens per second. So something happens divided by time. So that leads us to, well, how do you calculate acceleration? So acceleration is, no surprises, the change in the velocity divided by the time taken for that change to happen. And you can get 1 mark in an exam sometimes for being able to say that. You'll get another mark if you've got to be able to rearrange the equation. So I've wrote it there for you. Now, the change in velocity, I just want to note that it's the final velocity take away the initial velocity. Now they use v for final velocity and they use u for initial velocity. So you'll sometimes see the equation wrote as A acceleration equals v minus u over t. So that's final velocity, take away the initial velocity. In other words, the change in velocity. This triangle means change in, it's delta, Greek letter of the alphabet. So the change in the velocity divided by the time. And the way that I get my students to think about it, imagine you've came out of school, and you're busy texting someone, and then you look up after you've sent the text and you realise your mates are a little bit further ahead of you. So you're walking along at 1 metre a second, and then you want to run, so you need to speed up to catch up with your friends. Now let's just say that you were originally walking at 1 metre a second while you were sending the text message. To catch your mates, you've got to speed up to 5 metres a second, and it basically took you 2 seconds to catch your mates. You need to be able to pop that information into the equation. So here's how you do it. A equals v minus u over t. So your final velocity was 5, your initial velocity was 1, took you 2 seconds to change. The change was 4 metres a second if you've gone from 1 to 5. So 4 over 2 basically is 2 metres a second squared. Now you'll also sometimes get a mark for the units for acceleration. So if you are doing metres per second, then that's metres per second squared. Sometimes they'll ask you about acceleration and distance. This equation here was about acceleration being related to time. But sometimes they'll ask you for acceleration and distance. So you basically need to use this equation here. And it can be tricky because sometimes they'll ask you to rearrange this equation in order to work out a distance. So in order to do that, let's just make sure you're happy with this. So what I like to do is put some brackets around that, keep those together, and then basically I need to get distance by itself. So if I was to divide both sides by 2a, then that would cancel out 2a on that side and just leave us with x. So obviously whatever I do to the right hand side, I've got to do to the left hand side. So you'd end up with v squared minus u squared divided by 2 times by the acceleration equals the distance. Now for some reason students forget to multiply it by 2. I don't know why they do that, but they do that quite often. So using that, and especially rearranging that, can be worth another 3 marks. Remember, every time you get 3 marks, you go up half a level. Okay, so here's a little acceleration experiment that I do with my students just to bring to life that question. So I get someone to walk along. So there's a lad Kai, he walked at 1.6 meters a second, and then he ran to catch up with his mates, and when he ran it was 7.2 meters a second, and it took him 1.5 seconds to catch his mates. So work out his acceleration. So once again, acceleration equals the change in the velocity over the time. So that would be 7.2 take away 1.6 would give the 5.6 meters per second change, and it took 1.5 seconds for that change to happen. So that over that comes out as 3.73. And again, calculations can be worth 3 marks. 4 marks if they don't give you the units and they want you to give the units instead. And just out of interest, if the acceleration comes out as a negative number, it means that the object's decelerated. So for example, if they were going at 7.2 and they slowed down to 1.6, then that would be, the final velocity will be 1.6, and then take away the initial velocity, which would have been 7.2. So you'll come out with a negative number. And that means you've slowed down, decelerated, rather than speeded up, accelerated. Right, what is the acceleration of free fall? And how do I carry out an experiment to calculate it? So the acceleration of free fall is basically just the saying, how big is gravity? Well, gravity on Earth, and it's different on different planets. Gravity on Earth is 10 meters per second squared, which basically means if something was to fall for 1 second, by the time it hit the floor, it would be traveling at 10 meters a second. And if it was to take 2 seconds for something to fall and hit the floor, right, let's understand what acceleration means. It tells you how fast you get faster, if you like. So 10 meters per second squared means a 10 meters per second increase in speed per second. So a 10 meters per second increase in speed for every second that you are accelerating. So if you're accelerating for 1 second, then it's 1 times by 10. If you're accelerating for 2 seconds, then it would be 2 times by 10, which is 20. And if you fell and it took 3 seconds to hit the floor, then, you know, you'd be going 10 meters per second, then you'd be going another 10, which would be 20, and then you'd be going another 10, which would be 30 meters per second by the time you hit the floor. All right. If you do A-level physics, acceleration of free fall is actually 9.81, but at GCSE level, just say it's 10. They're happy with that, and that should be 10 meters a second squared up the top like that. 1 mark for knowing that value, easy. Right, now this could be worth a whopping 6 marks in an exam, so pay attention to this. This is the acceleration of free fall experiment to calculate the size of gravity on planet Earth. Right. So the question could basically be, right, and this is your 6 marker, describe an experiment you would carry out to determine the acceleration due to gravity. Now, tell the examiner what equipment you'd use, say how you would use the equipment, and show how you would use any equations. Right, if you've never saw this before, let us explain how to use it. Right, it's all wrote down there if you want to read it for yourself, but I'll just explain it. Remember, always base your explanation on the calculation. So acceleration equals v minus u over t. So we need to work out a final velocity, an initial velocity, and the time taken for that change to happen. And then because it's something that's fallen, the acceleration that you're working out will actually be the acceleration of gravity. All right. Right, do you remember, in order to get the speed of something, you do distance divided by time? So what we need to do, velocity is basically speed but with a given direction. So we need to use this equation to work out the initial velocity and also use the equation to work out the final velocity. Right, this is a light gate. What happens is there'd be a little beam of light coming out of that hole there and coming across onto a detector over there. Alright, now this card here will usually be about 10 centimeters in length. Now as you drop that card, and it's weighted, it's got a little bit of blue tack on the bottom, right, just to make sure that it falls down straight. As that card falls through this light gate, it breaks the beam, and this light gate would be linked to a data logger, which is basically like a little computer to record the information for you, so you don't need to worry about start and stop watches and stop watches, because if you are start and stop watches, it basically means you're going to get something wrong because of human error. So let the computer do it. Right, anyway, so this falls through the light gate and it starts a timer, and it knows what the time is, right? And then you've typed into the data logger that the distance was 10 centimeters. So the computer just basically does 10 centimeters divided by however long the time was, and it works out the speed. So this here, that data logger up the top, would work out u, the initial velocity. And then it would do exactly the same thing. The card would fall down here like that, and then it would pass through here. So this light gate here would measure v, the final velocity. So I'd have the initial velocity, the final velocity. All I need to know is the time. Well, actually, when this light first gets broken, it starts off like a secondary timer. All right? And the secondary timer keeps on ticking away until this second light gets broken. All right? So from there to there, you'd know what the time is as well. Okay? So that would be that time there is that time there. I've wrote it all down there for you. So this is each one of these you could get a mark in an exam. So 1, 2, 3, 4, 5, 6, 7. I've put 7 different things on there. So basically what I've said, that's how to write it down. Okay? So pause the video, have a look at that. And as it says down here, that is worth a whopping 6 marks. So you've got to make sure you nail your 6 mark questions. Otherwise you're going to drop an entire level. Okie dokie? So we've just covered about 21 marks worth of content. Obviously 21 marks worth of content will not come up on an exam, but it just proves that acceleration is quite a popular topic that the examiners ask you about. So we can't guarantee that acceleration will be on your final GCSE exams in year 11, but if it is, you know, because of your resourcefulness and your initiative, because of your willingness to go out and find out how to answer questions, you're increasing your success. So without further ado, just say well done and work hard and be nice. I'll see you in the next one. Bye for now.